Question is a particle moving in a circle of radius r in such a way that its magnitude of centripetal acceleration is same as tangential acceleration. If it starts from rest, sorry, if it starts from starts a a velocity v naught, then find the time taken by the particle to complete one revolution around the sun. So that's the question. You can imagine there's a particle moving in a circle, and at the very beginning, the velocity of this particle is v naught, and it is moving in such a way that the value of centripetal acceleration and the tangential is always equal. So when it will
So,
come back to the same, that's the question. Understood the question?
yes,
You can try for 2-3 minutes, then answer. Maybe you can try for 5 minutes.
the radius is not there.
Radius is given as capital R. You read the question in which the first line is written there.
Sir, alpha would be 45 degree if they are same.
Yes, so you have to equate the formula, then you have to proceed. So there are many ways to do this. Look at this. So what it says that the value of centripetal acceleration is same as tangential. So I'm writing AT equals to this. Now AT we can write as dV by d, and AC we can write as. So what we are writing is at any instant, not at t equals 0. So let's say at after some time t, you are at this location and your velocity is v value. So when we write the differential equation, we always write for the general case, not for the initial or final case. And from there we proceed. So this is a very simple case of a differential equation, and the various things you can actually explore while solving this question. So d by v square we can write as dt by r, and now you can integrate. So integration will give you the velocity as a function of time t, because unless you will not get the velocity, you cannot find the distance. Or to find the direct relation between the displacement and the velocity, you can go by the other formula, which is at equals to v dv by ds. So there are various methods to approach. So I'll show you three methods, and all method will actually let you explore how to start attempting problems like this. So let's
So
say I'm
limit
looking
should be
for,
0 to v naught.
pardon,
So limit should be 0 to v naught.
limit will be v not to v, because you begin with v naught, right? Isn't it?
Yes.
So you start when time is 0, your velocity is v naught. When time is c, your velocity is v actually. So once you have this value, you can proceed next. Now, if you integrate dv upon v square, it will get minus 1 by v,
Minus 1.
and this will become t by r. Now, whenever we have minus and we can remove the minus and reverse the limit value.
Change the limit.
So you can write like this. So the obvious step is substitute the limit, and so 1 by v, which is a variable, I want to write in terms of the rest of the quantities, which makes it r minus v naught t upon. So also we can see that velocity will have a very nice relation. I mean, a mathematical relation is there. So v as a function of time t, we have, and because time is required, so we need a time function. And now from v, what we can write? So v can be written as ds by dt, because that's a speed actually. So using, we can relate the time with displacement. I mean, distance travel along the perimeter of this circle. If you use this formula, what you can write next?
Or again integrate.
Yeah. So now because v equals to, we got as r v now. R1 is v. So writing this as ds by dt. So ds can be written as, and if you integrate ds, we can call it s. Just type on this. R and V not being constant, we can take it out of the integration, and what you are left with is this value. When time is 0 to time is t. So let's say you travel s value, and this integration is pretty easy. This is ln r minus v naught t because it's a linear power, and we have to take a limit from 0 to t. So therefore, the s value will be equal to r v naught. Okay, now we have to divide by minus v naught also because that's coefficient. Take it missed. I'm taking it outside, and then we have to put the upper limit. Upper limit is t. Lower, if you put 0, you will get a ln r. So the s we can get is minus r, and this is ln like this. You can take ln on the other side, and s by r. So you can add as e to the power minus s by r. You can take here and then take exponential. So these are the basic calculation that you need to get expertise of. So the v naught t becomes r into 1 minus e power minus s by r. So time as a function of distance traveled on the ring will have this answer. Now what I am asking is find the time taken to complete one revolution. So for one revolution, we can say that s equals to 2 pi r. The s by r we can replace by 2 pi. And so if I call time period t, and let's call it capital T, so this will become minus 2. So it is the time after which it will come back to the same point from where it began. Okay.
Sir, in the integration step, sir, no understood.
Okay. Okay. So this is the one way of doing it.
Sir, no understood. Done, sir.
Okay. So what is the other way of doing the same problem? So now again, the beginning of the equation will be same because we have to use a condition given, so we cannot change this. But because it's a circular motion, so we can always relate in terms of variation. So we can this is v dv by ds, so that directly relates the s part, and ac we can write as v square by r. Doing this will help you in getting the relation very easily. So dv by v becomes ds square. R is constant, so if you integrate from v naught to v, this is 0 to s, and then for you can write a v equals to v naught e power s square r. But we are looking for time, so we can just write as dv v as ds by dt, and we are done. You can see that we have done in one line, very few lines. So now the s term we have to bring on one side, so we can write as e power minus s by r into ds is v naught dt. That's it. And then you integrate from 0 to s, and this is time. So this will give you s is the variable, so minus 1 by r is the. If you integrate, you get e power minus s by r, and you divide by the coefficient, which is minus 1 by r. Then put a limit, so that the value of t will be, okay, so can address r by v naught. I mean, of course, you get the same answer with real terms. This is also one way of getting the answer. Now, what is the other method 3? Maybe. So method 3. So in the third method, so we can use the angular variables instead of these variables. So like the beginning is same, but we can write as something like at as alpha into r, if you remember, and ac as omega square r. So even we need to write even r. So that's interesting. And then alpha and omega we can relate. So this is omega d omega by d theta. So we can write as 0 to theta because you start from this. So instead of v naught, we have this one.
So can we do this question by canonical equations that I did yesterday?
So you cannot use the canonical equation for the obvious reason, because canonical equation, when you say, it is derived only for the constant angular acceleration. So unless the acceleration is not constant, we are not supposed to use it. We are supposed to derive it. Understood? Anyway, so now we can just convert this into omega naught to omega, because you start with some velocity, so you will have some initial angular velocity as well, and basically the where omega naught is nothing but v naught by r, that we can substitute later on. So this is again omega equals to omega naught e power theta. That's it. And for time relation, you have to go one step again ahead. So the omega we can write as d theta by dt, and if you bring e theta this side, it becomes like this. And if you integrate, it's the same thing. So the t will be 1 by omega naught. Now once you have the answer, you can convert it into the values given. So omega naught we can write as v naught by r, and theta we can write as s by r. So we are using the formulas theta equals to L by r, arc length. So again, you will end up getting the. Okay. So we have all the methods at place, and the very purpose of giving this program is so that you can see how to create equations from the given values. So I have given you all the ways of thinking and applying the formula. Just tell me.
So can we show the next?
Sir, in the last method, sir, we have that e raised to theta came.
Pardon?
In the
Tell me.
last method,
Uh-huh.
sir, that e raised to theta, how it came?
Okay. What is the integration of d omega by omega? What is the integration of dx by x? Ln x.
Yes, sir.
Yes, that's the answer.
Yeah, sir. Yes.
So let's go next. So next is I have shared some questions, as you can see.
Yes, sir.
Okay, so now I'll tell you the question number which we will practicing today. So all are from IE Rodel. If you have that book, you can bring it out. As you can see from there.
Sir, note the last page, last method point last.
The question that we are supposed to solve is 1.37, 1.39, 41, 1.32, 42, 46, 47, 48, 49. Yes. Done.
Yes, sir, done.
1.56. So now these are the questions that we are going to practice, and some of them I will solve, some of them will be homework. So you start with 1.37. I hope you all can write, I mean, read from shared value notes.
Yes, sir.
So 1.37, it's the bottom of the first page, I think. So in fact, we have to solve the 1.34 also, and 1.35, 1.36 also. Uh, just a minute. Okay, so in fact, we can start with 1.34. 1.3. Let me do this question then. If you want to read the question 1.34, you can read, and if you want to attempt, you can attempt also. So you first attempt this question. So at least you spend 2-3 minutes to read this question and understand. Then I'll stop. Try to understand the trajectory of this particle.
So the rising rate is constant, and the Vy is equal to constant.
Pardon?
So in that 1.34, the
Hmm.
balloon is rising with constant velocity.
It is written there. So if something is written there, you need to read this out. I think it should be constant.
So what is mean by ascension?
Going up.
Sir, in 1.34, I got two equations by integrating. Y is equal to V naught T and X is equal to half A V naught T square.
Y equals to V naught T.
Yes, and X is equal to half A V naught T square.
How you can say that? X equals to
Sir, I did like dy by dt is equal to V naught and then integrated both sides. And in
so
the second
dx
case,
Vx, yeah, Vx is given ay. So okay, you have substituted y equals to something
yes,
V naught T, right?
yes,
And then you have integrated to get x. So x will be half a V naught T square, right?
yes.
Very good. So that's correct. So now you can find everything. So what you need to do is you got the velocity x component and you got y component as a time function. So you can add the v vector. So write v vector and similarly try to write the a vector, the acceleration vector. So first write down that and then you'll get the other answer. I'll tell you what to get, how to get. So you write v in vector form and then write acceleration in the vector form. I cap j cap. Okay.
Yes.
How to do this. So you got the v vector, right? So
Sir, yes, I'm differentiating so that I can get expression tangential.
vy is how much? What is vy?
V
V
naught
naught.
T. V naught
The
T.
ay v naught t. Vy is vi. Vy is constant, na?
Yes, so
So ay is 0 and vx is how much? Ay. So dvx by dt if you differentiate, what we get is a dy by dt and dy dt is vy, which is v naught. So this is a v naught. So we got the ax equals to a v naught and we got ay equals to 0. So the only accession we have is the horizontal accession. So now the vector form we can write as a vector as a v naught I cap, and v vector we can write as uh, a y I cap plus v naught j. Yeah. So as a function of y, we can write like this, something like this. So now we have, let's say we have a and b, v vector. So what is the first question? The first question is find the tangential accession and centripetal. So what is tangential accession? If you remember that circle in any circular motion, if the velocity vector is known to us, let's say it's something like this. And so velocity is always tangential. Okay. And the acceleration part may have some two values. One is centripetal and other is tangential. In general, the total acceleration is something like this. And if I call this alpha, so the A tangential is definitely A cos alpha value wise. That's easy to understand. And the A cos alpha we can write as A V cos alpha upon V. And the purpose of writing this is so that we can use the dot product. So we can write as A dot V upon V. Basically, if you want to find the tangential acceleration, you have to just take the component of total acceleration along the V vector because that's tangential. This is V cap, and this is just from the vectors. So doing this will give you the answer. So A is very pretty simple. It's A V naught I cap dot, and V vector is having two components. One is uh, A Y I cap plus V naught J, and we know that only I will go with I and J will be 0. So you get the answer is A naught is A square V naught Y. So what we got is the what we are missing here. Oh, upon V modulus, like whatever is the magnitude of V. So the magnitude of V is how much? Can you see the V magnitude? Yeah, you can see that. It is under root of A square Y square plus V naught square. Yes. You can see that the A tangential is very easy. Similarly, you can find the A centripetal by taking the cross product, if you can understand. Because to get this answer, we need A sin alpha. I mean, that's the way to get it. So numerically, you can write as A sin alpha, and therefore you can write as A V sin alpha by V. So now this becomes a mod of A cross V. Doesn't matter. Just take a mod
Sir, but
and then yes, tell me.
sir, but we cannot write a square v naught y naught because sir, a is as actually in the question they have given a is a constant.
The small A is constant, but that's not acceleration.
Sir, I got same number. So
So
80.
then 80 will be so it will be different, right?
Come on, this A is different from this A. I mean, just because I have taken the symbol as A, you're getting confused. This is not this A. This is not A. The A I have taken is this A. Understood? This is the total acceleration vector. Don't get confused with this A. This A is a number.
So then in ay I cap dot av naught I cap. So they both are different a's now.
Okay, this A is the same. This is where is the confusion? Tell me.
So that up part.
Do one thing.
Sir, I got tangential acceleration as function of t also.
Just you guys are just getting confused with no reason. That's the problem. So you write it here as ky. Yes. No, sir. You get the same answer. So now this is okay. The k is the value. K is a number. It's not acceleration. So in any motion, let's say the way the particle is moving. I mean, I don't know how the particle is moving. What I can say that one thing is clear that if velocity vector is something like this, and if a vector is something like this, if there is the angle between these two vectors, and this angle like I'm calling as alpha, so we know that tangential is always the component along the velocity, and the centripetal is always the component normal to the velocity, right?
Yes, sir.
So I have no idea how the V is, how the A is, but I can say that at least they will have some angle. And for the obvious reason, because you can, if you even if you write in components, you can see the V will have both component X and Y, and A will have only one component X. So even if you draw proper diagram, the V is something like this, but A is something like this. And if I say this angle is alpha or whatever theta, then the tangential is that component of acceleration which is along the velocity, because tangential will change the magnitude of velocity. So I don't know what is the confusion. That's a straightforward thing. We have done this. So the AT we can attach A cos alpha. A is the total acceleration. Is this clear? A is the total acceleration. Is this clear?
Yes. So,
Yes, tell me.
so that v vector is equal to ky I cap plus v naught j cap. So if we find the magnitude and differentiate it, then also we will get the same answer.
Yeah, you can find the magnitude and you can differentiate. That's a nice way of doing it. So
So
there
I
is no
did that.
problem.
I thought same answer.
Even if you do the same, you will get the same answer. So you can take the magnitude of velocity and you differentiate it. That's actually a better way of doing it. So this is also one way of doing it without differentiation. In fact, you should do this and check that both ways you are getting the same answer or different answer. You can just check. What happened? So you got the answer? AC and 80?
Yes, same answer.
Yeah. So whatever you do, you get the same answer. So now there is a other way of doing this also. I mean, if you can do it third way also. So now, as we have discussed that if you trace the path of this ascending object, it is moving something like this. Why? Because at any instant velocity will have x and y component, and the acceleration will have just x component. So the acceleration we know is this much only, and the acceleration what we got is a v naught. You see the acceleration along the x-axis. So this a is a number, constant, not acceleration. I don't know why you get confused. And v vector is something like this. So if I call this as theta, you can find the theta easily. This is the v vector, and what is the v vector? It is ay I cap plus v naught j cap. Now finding tan theta is pretty easy. It's just v naught by a. This is a times y, not subscript. This is the a times y.
Yes. So
So what we can do next? So now once we get the theta, so it's very easy. So we can just write AT equals to AB naught, whatever is the value of acceleration, into cos theta. And because we know the tan theta, we can find cos theta directly. So I need not to take the dot and all product. So cos theta we can write from here is AY upon V naught square plus A square Y square under root. Yes. So we got this answer. AT equals to AB naught into cos theta, which is AY upon. So it is up to you. You can do it the way you want. And the centripetal acceleration is always this value, this component. So centripetal is always the normal component or perpendicular component, and therefore we can write like this. All right.
Yes, sir.
Yeah. So now AC we can write as simply A V naught sine theta, and again we can do the sine theta from there because we have tan theta value, so sine is this upon. So there are a variety of ways in which you can manipulate the kinematics of circular motion. So you can play with this, you can learn, you can apply and do whatever you want. Okay. So now you can go to the next question. Which question is next? Let me just see that question.
1.3.
Yes.
So which one?
So I have given all the list. You can go one by one.
Yes, sir.
So the list is here. 1.37. I think you can go to 1.37. Just open it. So 1.34. Okay. Okay. 3.5 is the equation of trajectory. So that's okay. Yeah, you can solve 1.36. It is very much similar to what we did. And I'll tell you what the meaning of this symbol. So maybe this is the first time you're looking at this symbol. In the question of 1.36, there is a very new symbol for that's W tau. So actually, this refers to something like A is a number. So this is basically you can say tangential acceleration equals to A dot tau vector. That's meaning actually. So you can read something like this. You can think this as A dot tau. Tau is a tangential unit vector, and that is because it's unit vector, so the magnitude is 1. So this becomes A t equals to A cos theta, where theta is angle between acceleration and tangential unit vector. So what you can do is instead of solving this complex looking symbol, you can just convert this into this value, 8 like this. And then you can see the diagram is on the next page given to you. You have to just draw some diagram and then you can realize it's not very difficult, it's very easy program. Maybe you may find it difficult in the beginning, but that's it. So at any location, the constant vector, the A is a vector, constant vector. So A is like this, and the tau vector is like this. This is the unit vector, tau vector, and this is the x. So what we are supposed to find is find the velocity of the particle. Okay. The question is find the how the velocity depends on the exponent. Okay. So we can say that what we can say. If you take some angle theta, so what is the tangential vector? What is A tangential? It's definitely A cos theta.
A cos theta.
Yes. So this we can write as V dV by dx because sorry V d by ds not dx. So V d by ds we can write as A cos theta, right? And this turns out to be V dV equals to A ds cos theta. If I take a ds something like this, and theta is like this, so what is the ds cos theta representing? This is basically dx. So now we have the simple relation that V dV is A dx, and now we have to integrate. And if you start from rest, and A is constant, so that's if you start from rest to V, this will become x, so this will become V square by 2 equals to ax. So V is under root 2ax. So you can see that although it looks very weird question, but eventually it converts into a very nice expression. Okay. So this is difficult for you guys, so no need to worry. Go to next question. This is 1.36. It's challenging for you. So unless you do not have the habit of drawing the vectors and understanding that how it looks like, so ds cos theta suddenly becomes dx and becomes a meaningful thing. Okay, so go next. Question number 1.37. So you want to try this question 1.37 or shall I solve this question?
So times
Good.
So in 1.36, that WT equals to A tangential unit vector. So that
See,
it is a function of acceleration.
no. You have a big problem with understanding symbols. That's the problem. So it's pretty simple. I mean, A is written as constant vector. It is not acceleration. In everywhere when you see a, it does not become acceleration. I mean, a is a number. So if you're confusing with the acceleration a and a of a number, then you change the symbol, then solve it, and at the end substitute the value.
Sir, I'm
Whether
asking
it's
about WT.
wt, okay, w tau.
Yes, sir.
The w tau is called tangential acceleration.
Yes, sir. That will be.
Basically, in aerodynamics, w is used for acceleration. So because they use w for acceleration, that's why they use a for other symbol, constant and all. So the Russian having the very weird way of doing things. Okay. So w tau is the a tangential, and a is a vector which is constant vector. And when a and tau, which are both vectors written together, so it means it is dot product. So that's to understand why it is so, you need to go back to the first page of Eroda and read the preface and read the explanation of symbols and meaning. But anyway, that's a dot product. So that's why I've written here. Understood?
Yes, sir.
Sir, in 1.37, I got both values, 80 and 84.
So now so you have to solve the question number 1.37 now. So I think this is easy, no? This is like you have to think of
Yes.
yeah, whatever you can think is, it's up to you.
So 0.8 meter per second square.
So in 1.37, what they are saying is, look at this.
Hello, sir.
Yes, tell me.
So 0.8 meter per second square.
Okay, answer you're asking. 1.37. The answer is 0.8.
So yes.
So is that your answer?
So yes.
Okay, very good.
So first I was getting in terms of pi. So then I calculated the parameter.
Correct. So V is given as a time function, so you can differentiate to get the tangential acceleration directly. A is a number, and find the total acceleration of the point at the moment when it has covered nth fraction of circle, which means n into 2 pi r, right? So because V is given as at, dv by dt can is a. So basically, the A tangential is a. Okay. So we are supposed to find the velocity because A tangential is constant. So you can in fact use canonical equation as well. So we can use the V square equals to U square, or you can differentiate them the way you want. So you can do it by calculus. Keep it with calculus only. So V dV by ds, and you just integrate. So you can see that when time is zero, V is zero. So you start with zero, and you travel n fraction of 2 pi r. So nth fraction of the circle. So V square by 2 is A into n into 2 pi r. So you can see the V square by r is how much? 4 pi a n. This gives the directly centripetal acceleration, which is 4 pi a n, and the tangential is already known to us. A, P is A only. Therefore, the total acceleration will be under root of AT square plus AC square. AT becomes A square plus, you can take A outside and it becomes 1 plus 4, 5. So this is how you can get this answer easily. Now 1.38 we have done, so that's nothing to do with it. You can go to the question 1.39. So I hope this is clear to all of you,
Yes, sir.
and I hope you have also realized that the kind of question which is important in this chapter is these questions. Okay. So if you look at the JEE examination, I mean what JEE has been asking, so they ask question from the canonical part because that requires calculus, manipulation, and many more things. Okay, so do this question quickly. So as soon as you finish, I can go to the conventional question of circular motion. So 1.39, and then after that, probably I'll leave as a homework. The rest you can practice at home. Then I'll go to the next topic, like concept. So the last question. This is the last question that I will help you with. And then rest, it's up to you. You can do more on the
So we have to attempt 3.1.39.
Sir, is it tan inverse a square t by 2r?
Hello, sir.
Hello, sir.
Hello, sir. Sir, you are not audible.
Oh, sorry.
Sir, I got the answer. Sir, but I got the answer for the tangential acceleration and the norms.
Sir, I got the
The
same answer.
resultant
Tan inverse
acceleration.
2s by r.
Hard to
Yeah, correct.
that only.
Yeah, so you have to draw the circle and then draw the AC and AT direction. Then the total acceleration will make some angle. Then take the ratio. So tan alpha is always
AC by
tan
AT.
alpha is always AC by AT, and then substitute the value accordingly. We get the answer.
So just one question. They asked for the angle between the velocity and the
Beta velocity is
the
always parallel to the tangent, isn't it?
yes. So
Yeah.
so
So
that's fine.
so you can do the same thing. Okay. So now we can go to the next concept, and that's called, it's very important, and that is called radius of curvature. So we are going to learn next is, so we can call it ROC, and the technical symbol we use is rho. Actually, we don't use R. R is meant for circle, but this is meant for any curve. So the radius.
So your voice is not very clear.
Hello, hello, 1, 2, 3. Am I audible?
Yes, sir.
Okay. So now the idea is the center of this circle which you drew at the point P is the center of curvature, and the distance is called radius of curvature. So we call it R. Now The R can be calculated in two ways. One is called the mathematical way. Another is called the way in which physics is explained. So, in terms of physics, to find the radius of curvature, we need two things. We need velocity and we need total acceleration. So once you give me these two values, I can find the radius easily. How? So also I need single theta. Let's remove this. Okay. So the idea is simple. To find the radius of curvature, we need centripetal acceleration. So if you give me a and theta, I can find the centripetal acceleration easily. It's a sin theta. But since you have given me the velocity also, so we can also write this as v square by r. And because I have two equations to write the same thing, so I can find the radius of curvature, which is nothing but v square by a sin theta, or you can write as v square by ac, or you can write as something very interesting. What you can write? The radius of curvature you can write as v square by a sin theta, then multiply with v and divide by v, and this becomes mod of v vector whole cube, and this becomes a cross v. You can just take the cross product of acceleration and v. So we can, in mechanics, we write like this. Like if you know the velocity and acceleration, this relation can be obtained easily. So this we also write as this upon a perpendicular. The acceleration which is right angle to the velocity is always ac. So that is what you need to remember. So this is the way to find the radius. So we need to derive this. So I can go next page. Yeah, next page.
Sir, so in circle, magnitude of centripetal acceleration is only radius of curvature.
You see, if you know the acceleration, let's say if you know the acceleration which is c, centripetal is that acceleration which is right angle to the velocity. So you may not be able to see the circle, but you can see the acceleration. And once you can see the acceleration, you can find the component which is right angle to the velocity. So the moment you get that component, that's always centripetal. So whether you see the path as a circle or not doesn't matter. But what you can see is anytime when we have v and a, see if I draw some random velocity and acceleration vector, if I just say this is v, this is a, so the component this is always ac, no matter how arbitrary this diagram is. You can look at these circles, the circle just drawn, but if you look carefully, the a and v make some angle, and then what I am taking is the component of a which is right angle to the velocity vector, that turns out to be a sin theta. So the centripetal acceleration is always right angle to the velocity vector. So we don't resolve v, we only resolve a vector. And because the formula for circular motion we know already, v square by r, so we can compare and then we can get a row. That's the idea. Okay. So we can do some problem before we go to the mathematical part. So this is a very famous question. If I have a projectile, if I throw a projectile in air, it goes and so imagine if I throw with speed u at angle theta. So of course the only force acting is gravity. So the only acceleration is the acceleration due to gravity, which is free fall acceleration g. So my question is to you is find, now this is a parabolic path. So every parabola is a curve. So it will have some, every point of this curve will have some, I mean, center of curvature and show the radius of curvature. So find ROC of path of projectile at one point of projection, and two is at maximum height. So try this. This is a very simple method. You should do.
So,
Yes, then
sir, the maximum height will be u by g cot theta.
see the question is find the radius of curvature at the maximum height of the journey.
Yeah, so the radius will be u by g cot theta.
Okay, so I think okay, look at this. So what is the answer at the bottom? So see, to find the answer, the rule is you first find the velocity vector. So we know the velocity vector is horizontal, and we also know the magnitude of this velocity is u cos theta. And
Yes,
then
sir.
check the axis. Axis is like this. So this is already perpendicular. So the ROC here will be directly u square cos square theta by g. That's the answer. So what we have the formula? The ROC is how much? V square by a perpendicular. That's it. At the point of projection, the G is this way. So G is not at right angle. So we need to find the G at right angle to the velocity. This is G cos alpha or theta. So this answer becomes U square by G cos theta.
Well, just
So
one question.
you're not
At
getting the
max
idea.
height, it should be
At max
2g.
height, look at the velocity. Look at the acceleration. I mean, the
Last
why the
question.
problem is with looking at the velocity and acceleration. I mean, I really don't understand that why you fail to understand what is velocity, what is acceleration. So it's a pretty straightforward thing. Like you just check the velocity, check the acceleration, find the component of acceleration right angle to the velocity, and then just write the equation. That's the answer. So ROC is simply V square by AC. So you cannot.
Serious investment.
Ch01.
Hey, you're not audible.
Okay, so imagine we take a case of a parabola, which is very famous. In parabola, generally the interest will be at the bottom most or the topmost point because this my parabola is vertically upward parabola. So we know that at the bottom the tangent is zero. I want to know the radius of curvature of the bottom point. So maybe the bottom is a part of this circle. So I want to know this radius. And this is given by the formula, let's say y equals to ax square. I'm just saying a random formula. So we can find the first derivative, which is 2ax, and the second derivative is pretty easy. It's only 2a. So at the bottom, because the tangent is 0, so the radius of curvature of this point, ROC of this point, we can always write as 1 by. Okay. So this is the formula of the radius of curvature at bottom one. So not for other point. This is bottom. In fact, we can do it for the projectile also. So in case of projectile motion, if you remember, the equation of trajectory we write as x tan theta, where theta is the velocity of projection, minus gx square upon 2u square cos square theta. So the dy by dx will be how much if you differentiate? It is tan theta
Then
minus.
multiply.
So I'll just write this in simple notation. The y double dash is how much? So at x equals to 0, that is the beginning here, the point of projection, the first derivative becomes what? So y dash becomes tan theta because x is 0 if you substitute in this equation. And y double dash is independent of x, anywhere you will get the same answer, which is minus. So the ROC at x equals to 0 will be 1 plus y dash square power 3 by 2 upon y double dash mod. So 1 plus y dash is tan theta, which is tan square theta, which is nothing but the sec square theta. This is value by g square by cos square theta. So this becomes sec cube theta into u square cos square theta. This turns out to be u square by g cos theta, which is exactly same answer as we got earlier, but now using the mathematical function.
Sir,
So
this is a formula for
the formula for radius of curvature is this, and you can apply in any graph.
yes, sir.
Okay. So now one particular situation where we are interested in applying the mathematical formula, there are two situations. One is parabola. So we are always interested in any quadratic function. So if you have a quadratic formula, you can apply this. The other scenario in which we are also interested is called ellipse. Because in chapter of gravitation, we need to know this particular concept. So if we have an ellipse, so we cannot write the function for ellipse because ellipse at 1x we can have two values of y. So we can only write for the first quadrant, but the way to do is simple. So for this ellipse, let's say the center is at origin and the major axis is a comma 0 and semi minor axis is 0, b, let's say. So the formula for the ellipse is what? What is the equation of ellipse? How we write it? X square by
Y square by x.
so if you differentiate this, let's say 2x by a square plus 2y by b square into dy by dx, which I will write as y dash. So what we are getting is y dash by b square equals to, I mean, plus x by a square equals to 0. Okay, so now you can differentiate once more. That's tricky one. So y by b square can take common, and y dash will be y double dash plus y dash by b square common, and then you will get y dash again the second time, and this become 1 by a, a square. So what turns out to be like y double dash y upon b square plus y dash square by b square equals to minus 1 by a square. So y double dash plus y dash square equals to minus b square by a square. So it's difficult to separate the things, and that's why we are not interested. Like if you give me the location, I can. So now here the y dash we can get from here. So we can do this. So y dash by b square is minus x by a square, and y dash is minus b square by a square into x. So we can replace, we can get y dash from here. That's okay. And we can replace y dash. I mean, let's not replace, let's keep it like this. So look at the location distribution. So we know that at this particular location, the slope is 0. So finding the ROC of this point is pretty easy. So we know that at this location, so this is a
Y
big
dash
circle.
is equal to 0.
Yeah. So if you put y dash equals to 0, the numerator will be vanished. So we have the second derivative mod is the answer. So we can directly get this answer. Now the second derivative I can get from here easily. How? Y value we know is b. Y double dash I'm looking for. Y dash is 0 equals to minus b square by a square. So now I got the answer directly. So one b will cancel out. So y double dash turns out to be minus b by a square. And therefore the radius of curvature of the topmost one, let's call the point P.
A square by b.
Correct. It's a major axis is square by b. Now it turns out to be because of symmetry. If you try to find the ROC of this point, although we cannot apply the formula, but we can invert and we can do this. So technically the ROC of this leftmost point, it may be very small circle. If I call this point as Q, R of Q, we can just write by symmetricity b square way. Or you can tilt the, I mean, turn the ellipse by 90 degrees, then do the calculation. It's the same. So it is always the, I mean, symmetrical value. So for ellipse, we know that ROC of the topmost point and the leftmost point, because these 2 points are of our great interest. The rest we do not need actually. So even in order to solve problems, I mean, these are the things which we are interested. Rest we really do not care about. Okay. So the ROC part which we need is only this much. We do not need much of things. And now we can go to the dynamics part, like the part which you are waiting for.
Sir, just can you show the last page?
This one.
Yes, sir. Done, sir.
Okay. Okay, so now let's start this. So now what we're going to learn is called dynamics of circular motion. So we are done with the kinematics part or all the calculation. So every question of circular motion needs certain steps, and if you follow it carefully, you can always solve the question. So this is so simple. So in every circular motion, what we know? We know that there are two types of acceleration. So the way to solve the numerical is pretty simple. So you can take the tangential as one direction and the line joining the center and the point of motion as one direction. And the total acceleration you can again draw, of course. So the laws of motion part, if you talk about the laws of motion, so there are three way of writing. You can add net force is mass into total acceleration. Just so you just add all the forces and you just add m. This is one way of solving. Or so don't write the total one. So you can do individual. So what you can do is resolve the forces along the tangent and along the center. So now while resolving the forces along the tangent, there are certain things that needs to be taken care of. And that is the force supporting the velocity or opposing the velocity? So if it is supporting, we write plus. If it is opposing, we write minus. So while you write all sum of all force, you have to write plus and minus sign. And then you can write m80. So you cannot write total acceleration, but you have to write the tangential acceleration only. Now similarly, while writing the net centripetal force, we need to resolve the forces along the radial direction, this direction. Now centripetal is towards center, so every component which points towards center is positive. So into the center is positive and out of the center is negative. So something which points towards the center we take as positive value. But if a force component is pointing away from center, we take negative. And then we write as MS. So So this is the too simple approach. I mean, you can either write net force and then, because that is not preferable in most cases. So we always go by the component. So what we do is we resolve the force along the tangent and parallel to the, normal to the tangent, or you can say toward the center. And what you can see that these two are mutually perpendicular direction. So the components are independent. So once you resolve along these two directions, which are by default mutually perpendicular, so things will be easy for you. But is that enough? The answer is no. So we need to be think more about it. So now, what will be the steps to solve the question of circumference? So now when we switch from the rectilinear motion to curvilinear motion for the first time, it is a hard time in realizing that one equation is not enough. So normally we write F equals to ma, and that is always tangential, and we are happy with that. Now here things will change. So you need to be very careful. Like you should not be get carried away by the formula F equals to ma. So here you need to think about the two direction, the centripetal, tangential, and so on. So once you see these two directions, then only you can move forward. You can do some calculation. Okay. So how to go about solving a variety of problems? So there are certain steps which we need to be following religiously. The first step is identify the plane of motion. So when you look at a particle performing circular motion, it can be horizontal plane, it can be vertical plane, it can be some inclined plane, tilted plane, so it can be any random plane. So the idea is when you describe a circular motion, you need to be very sure that what is the plane in which things are happening. So plane is a very important concept. Sometimes it happens on a vertical plane, horizontal plane, and of course, sometimes it may happen in on a inclined plane. So these are the possible scenarios in which circular motion may take place. So we'll start with the horizontal one, and in the next chapter of work, energy, and power, we'll convert this into a vertical plane, and we'll solve questions there. Now, solving question in every plane will have a different constraint, but the method will not change. So, what the method which I'm going to describe, that is going to be same. So you need not to worry much or change your strategy to solve questions from various sectors. As long as it's a curvilinear or circular motion question, the approach is 100% intact. So if you can follow this method, then things will be really good. So the step one is so the approach is simple. Identify the plane of motion. So having said that, okay, you have identify how the plane is. The step two is very important. So it is not necessary that you will be always lucky to find the force in the plane of motion, and then the only job is to resolve along the tangent and along the center. What if the force is not in the plane of motion? So imagine we have a so let's say we have a circle. I mean, this is, let's say, a horizontal plane, but the force is acting something like this. So here force is not acting on the plane. So I may resolve this force this way, maybe some F cos theta. But I will also have component like this, F sin theta. So this kind of resolution is called resolving the force along the plane and normal to the plane. So once you identify the plane of motion, check for the forces, and once you check for the forces, the next job is resolve along the plane and then normal to the plane. Okay. Now, when you resolve the force along the plane, it is not necessary that the force which you have resolved along the plane, it may act something like this. I mean, it's not necessary that it will act toward the center. So let's say F cos theta is like this. What if F cos theta is something like this? So once you get the force in the plane, then we resolve further. So I need another angle, maybe alpha. And then I will resolve the F cos theta further as F cos theta cos alpha,
Cos alpha.
and then F cos theta sin alpha. So the situation like this will never appear actually. That's why, I mean, this confusion will never come. But maybe JE may ask some fun day, something like this. So generally, okay, such complexities are not seen. You will have very nice problems of simple situation. But the strategy which I'm trying to design is independent of the nature of problem. So you choose any problem, follow the step, and you're bound to get the answer. So that is I'm guaranteeing working. So this is a like guarantee scheme. My guarantee is that you will get all answer. The only condition is if you follow. So what is the step two? So if I put into words the step two, then I'll say that resolve all forces perpendicular to the plane of motion and parallel to plane of motion. So the step three is resolve one more step. So in the step three, so that says that the parallel forces should further be resolved into two components, one along the tangent and two along the center. Now, the most important part, step two. And what is that? So all forces which are in the perpendicular direction, that is normal to the plane, all forces acting normal to the plane of motion must be in equilibrium. That is, summation of all normal force must add up to zero. So that is the only step. And once you do this, the remaining step is already in the bracket on the leftmost corner of this white blackboard. So what you need to do next is once you come to the step 4, then come here. This is your step 5. So if everything is done, then you come back to here and use this or this. I mean, of course, you have to use both or maybe one. So first you design this algorithm in your brain, and then I'll move to the next problem. Is this clear?
Yes, sir.
So you need to actually master these steps. This is very, very important. And once you master, then everything is easy. Nothing is difficult. So
Sir, I was writing that. Sir, done.
now this is a very generalized approach to attempt any problem. And also what I said is you need to be careful about taking the sign into consideration. So while writing the centripetal force, when you add all centripetal force, the one which acts into the towards the center, that is positive. But the one which acts away from center, you should take as negative. So the realization of center is also important. For example, if I talk about a oscillating pendulum, so let's say we have something oscillating. So I think this is easy to understand. This is the center, the point of suspension is the center, right? So once you know this is the center, and this is the tension, this is the mg. If I say this is theta angle, what is the centripetal force? I mean, just let's practice the center. What is the centripetal force? If I want to write, what should I write?
So T minus mg cos theta.
Very good. It is definitely T minus mg cos. So imagine if we have a car moving on this track, and maybe the car I'm representing as a box, and the gravity is acting down. So what is the centripetal force here? In this?
So is this a horizontal plane or 2D line?
Vertical plane. So, so both are the example of vertical plane. So
Mg
only I
minus normal is equal to m
that
into AC.
yeah, correct. So that m into s. So now we're just practicing how to write uh, the formula for net or the net centripetal force. Imagine at this point, what is the net force along the tangent? So what is the net tangential force?
Mg sin theta.
And that's the only force. And this equals to, you can say m8. So in fact, you can find that tangential extension directly, which is g sine theta. So the idea is very simple. Once you know it's a circular motion, you have to write this way only. Once you know it's a curvilinear motion, you cannot write F equals to M A T. So you have to write F tangential is M A T, and then the centripetal must be written also. Okay. So what next? So we can start the program. So we'll start with something called horizontal circular motion. And the first question is called negotiating a horizontal or negotiating a curve on a flat road. So what does it mean? Imagine we have a track.
So during taking up from the car is tilt
Okay.
inside me.
Pardon?
So during taking a turn, the car will tilt inside or inside me.
Yeah. Oh, okay. Let's keep the complete track. Okay, this is a track. Okay, that's okay. And let's bring some bicycle or bike. Bike is okay. Bike. We are bringing bike. Actually. So we'll draw the simplified diagram of the bike. Okay, it's like I can draw this easily. So the bike tires. So when you move on a track, you always tilt towards the center, the way you want to turn. If you're trying to turn left, it is natural to tilt left. We'll see that why we tilt. Okay, so this is a, you can say, wheel. And okay, let me do the handle also. Okay, a potential diagram of the bike. Okay. So how we go about things from here? So first of all, we need to realize that the forces acting. Okay, so of course, the rough patch, and we are also going to learn something called UCM, the uniform circular motion. If you remember, so we are not going to change, the velocity part. So velocity part we are not going to change. We are not interested in velocity. We are only interested in the uh, change of direction. We will not consider velocity. Okay. Okay. So what next? So if you look at the basic forces, I mean FBD, that is what we do normally. So the ground will apply the normal action. So I'm just doing it like this. It's normal action applied by the ground, and gravity will act at its center of mass. So let me apply the gravity here somewhere. This is this. So now we have two forces, mg and normal. And now the next step is, can you identify the plane of motion? Can you
Yes.
identify the motion? The answer is yes, we can identify. That's not a big deal. So once you identify the plane of motion, you can see the forces normal and mg. Are they acting along the plane or normal to the plane? How they act?
So normal to the plane.
And we know that for circular motion, we need some force along the plane. Like the plane in which you want to negotiate the motion,
Yes.
we need some force. And these two guys are doing nothing actually. So because these forces are normal to the
Friction.
plane, the rule is simple. The net force normal to the plane must be zero. So they are balancing each other. So the N and mg are just balanced force. This is the first expression we get from the step, which is the last step in fact. So I use the step 4 as a first step. That's it. Okay, so now the first step is done. So now we need to ask question that who will turn this the bike? Now which force will do this job? So we have no force left actually. So we have the only one force left, that is the friction. And the nature of friction is it acts opposite to the tendency of relative motion. So because the bike is trying to tilt towards the right, so friction will act towards left. Now you may ask, why not like this? Why not like this? Why not like this? Why this way? Why only towards the center? So you can argue why only towards the center? Why friction will act towards the center only? Why? So the answer is, if friction will not act towards center, then it will change the velocity. But that is not we are trying to do. It will change the magnitude of velocity, the speed. But we are looking for the uniform motion. So if you look at the circular motion, if you look at the top view, what if the friction force is acting at some random direction like this?
So
Then
it
this will
will
have,
change.
yeah, so it will have two components, one towards center and another like this. And this will be dangerous because this will change the magnitude of this.
Velocity.
So it means if something is moving with uniform speed, not velocity, if something is moving with uniform speed, one thing is clear, and that is the friction has to act exactly towards the center. So there is no other confusion. I mean, it will act towards the center. That's it. So now the next question is, if it is acting towards the center, which friction is this? Is it static or kinetic?
Kinetic.
So why it is kinetic? Like what prompted you to say it's kinetic? Tell me why you're saying it's kinetic.
So because
So a wheel never, skid on the surface. So when you drive a bike, ride a bike or drive a car, the wheel always roll on the surface, and unless you do not rub the surface, there is no question of kinetic friction. So do you see that when the vehicles are moving on the road, they scratch the road while moving?
no,
So if they're not scratching the road, then there's no question of kinetic friction. So the only friction you can think about is the static. Understood?
yes,
So what you are supposed to think here is that the friction force will be static. It's not going to be kinetic. So when you negotiate a curve, it is the static friction which let you turn. So the absence of static will let you slip. And static friction is a self-adjusting friction, so it can change its value as per the speed of the vehicle. So we know that every static friction can go from 0 to a certain upper limit called limiting friction or Fs max. So if a bike is moving at certain speed, it will be able to turn. But if it really move fast enough, then friction won't be sufficient to make that turn possible, and therefore you will skid. So it is the friction which decides the maximum speed of negotiation. So when you negotiate a curve, so the velocity is dictated by the Fs. Okay. So the only equation I think this is very simple equation. I mean, the only formula we need to write is F C equals to ms, and we're done. So what is the net force towards the center?
new west energy.
The net force towards the center is how much? Look at the ABD and then tell. Don't bring your own ideas into picture. So what is the net force friction? I mean, it is the net force acting towards the center. Look at the ABD, then tell the answer. Tell me, guys. Like, open your eyes. You need to look from your eye, actually, not by your brain. Just look at the diagram. Do you see some force acting?
Fs,
Do you see some force acting towards the center?
Fs
Fs. And now Fs having no formula, as you should know. Fs will
is
have no
equal
formula.
to sir, yes, Fs. Only Fs.
Pardon?
Sir, Fs only.
Fs only, correct.
Sir, because new SMG also depends upon a very varies. So that's why. Sir, so
Okay.
Fs is equal to m into v square by r. So,
Yeah. So the only question of that is Fs equals to m v square. That's it. So where r is the radius of curvature. Pretty straightforward. So now Fs is mv square bar, and now we can write as the condition for safe negotiation or safely turning. So condition for safety is what? That the friction which we need to make this turn should be less than Fs max. So make sure that you turn with a speed which is not demanding as high as Fs max. So demand should be less than the supply, or maximum equals to supply. Safer is keep it less, which means mv square bar is the demand and the supply available is this. So this should be the case, and therefore this gives you the answer that v square is less than mu s gr. So v must be less than equals to under root of mu s gr. So v max we can say is under root of. So the maximum speed depends on the maximum coefficient of friction between the tire and the road. So the maximum investment a rider should do is on the tires. If you are very much fond of speed, then you must take care of your tires because that is what will save you. So the life and the death depends on Vmax. Understood?
Understood.
Yeah. So that is idea. So idea is pretty simple. The Vmax is this. So as the vehicle becomes expensive, you will see that the tires also becoming expensive because the price of the tire plays a big vital role in making a turn and bearing the stress because every turn creates a lot of stress in the tire. So the Ferrari tires are like very expensive. One tire costs more than lakhs, and they change the tire in one lap. So when they stop at the pit, they change the tires after every lap because the wear and tear which it undergoes while making the negotiation because they turn at very fast speed, so that requires tremendous friction. But the simple fish do not work there, so they have very specialized kind of mechanism to create this extra friction. So they create the extra friction using the chemical reactions. So the tire of the Ferrari, when it moves, it becomes greasy. Greasy means it will stick to the ground, and that only happens at the high speed. So at high speed, the tire behaves very differently than at low speed. So that's very interesting.
Sir,
So
does the
is
heat develop affect it?
yeah, of course it affects. On a cemented pitch, one should not drive very fast. Why? Because cement cannot absorb heat. Asphalt can absorb heat and will expand. So as the tire will become I mean, like hotter and hotter, it will the gas inside will expand and it will burst the tire. So on mostly Mumbai Pune expressway, there are a lot of accidents because of the high speeding bursting of tires. So asphalt is always preferred over the cemented road. Cemented road is also now in vogue because of the durability, but it's not safer for the cars. So anyway, if your tire is really old and you're driving on a cemented road, make sure that you don't drive very fast. Yes, it happens also on the Yamuna Expressway in Delhi. It's a very common event. You can search in newspaper and come to. And once the tire will burst, what will happen next? You cannot control the vehicle. That's the problem. So the accident is not because of bursting of tire, but because of the loss of control. Okay, what is next? So you have made the negotiation, but this is something interesting that every negotiation will make the tilt natural. So the question is why this tilt happens. The answer is very simple. You can think this way. The normal and the friction are called the surface contact force, so it will have a resultant. Let me take it. So the resultant of these two forces, called the surface contact force, this is the reason behind the tilt. So it is the natural for the body of the vehicle to align itself along the RA, because if it will not align, if the net reaction force will not pass to the center of mass, the bike will wobble. It will start shaking and you will lose control eventually. So while MotoGP race, if you watch, while turning, many loses the control and it starts wobbling and you cannot stop it. That's not your control because friction will be very variable, like very much random direction. So the tilt is natural to which let the net force passes through, passing through the center of mass. And because R is the resultant of Fs and N, so theta we can define in terms of Fs and N. So tan theta we can always calculate as Fs upon N. That's simple. So how much it will tilt is pre-decided. So Fs we know is mv square by R and N we know is mg. So we can see that tan theta is nothing but v square by R. So now you can understand that if you want to turn very fast, if v will increase, then tan theta will also increase. And tan theta will increase means theta will increase, which means the bike will tilt more towards the surface. So in the MotoGP race, you must have seen that why they almost touch their knees. They have, of course, knee guard, but the bike is almost touching the road. They hug the road. So now you need to know why this is required. This is needed.
Yeah.
So it is needed because else, unless you will not tilt, you cannot make the negotiation at that high speed. So the skill is lies in the tilting the bike at optimum value as per the speed value. So because the bikers are really lightweight, they are not very heavy bikers. They are lightweight for the guides. So they have very less weight. So they tilt by pushing the handlebar towards the ground, and therefore they shift the weight of the body also. So to create the torque, they shift their body weight accordingly. So if you see that they almost hang from the bike. So the idea is to shift the body weight to create that much needed tilt actually, because at high speed the bike requires too much torque to tilt. So if you fail to tilt, you will fail to make the negotiation. So all things are governed by the simple formula of physics. But physics, knowing the physics will not make you a writer. Okay. But this is something which one should know why tilt is required. Okay, so these are the questions that generally we come across in horizontal circumference, and we can see that friction is putting the limitation on what is the maximum speed at which I can make the negotiation safer. But we are human and we are ambitious, so we will not stop here. So we want to make the negotiation, and we also want to increase the speed of negotiation. So what we can do next? So here comes the concept of banking of law. So the purpose of banking is to make this negotiation more safer than making it on a flat surface. Do you have lecture after this? I mean, can I extend for some 10 minutes?
Yes, sir.
Yes.
So look at the purpose of banking, why banking is required. So this is a race track somewhere. I'm taking a cross-sectional view. So generally, race tracks are designed like this: the car racing track, and even in the, for bike, because they want to skill the driver's ability. So they do not care about the banking, because the bikers can tilt their bike, but in with car the problem is you cannot tilt the car, right? So car will tilt on its own only. So that's the only problem. So in the car racing, they create the banking like this. You must have seen maybe. So this is the track, and this angle is called the angle of banking. So basically, banking means tilting the road from the outer edge will be. If you have a road, then outer edge will be elevated compared to the inner edge. Elevation of outer edge with respect to inner edge is called bank. So to bank means to rely upon. So you can say you can bank upon. So you can rely on this track. So it will help you in making the negotiation without getting hurt. Just a minute. Okay. So imagine we have a banked road, and it's a smooth road. I mean, that's not possible, but I'm assuming. Okay, so there are many things that we need to realize. So if I only draw the cross-sectional view of the road, I'm not drawing the entire track. But I hope you have realized what is this track all about. So what I'm showing you is the cross-sectional view of the track, and you can realize this is how. This is like this. Okay. So I hope the picture is clear how it is. And
Yes, sir.
then a biker is a car or driver or whatever, like, is moving this way. So when you move like this on at a fixed height from the, so you are always part of this track. And if you look at the plane of motion, this plane is which kind of plane? Is it a horizontal plane, vertical plane, or inclined plane?
Inclined
No.
plane.
Inclined.
So you guys having again no sense of visualization, which you need to develop as soon as possible. So you're moving at a fixed height. How it is inclined?
Horizontal plane.
Correct. So this is horizontal plane. I mean, that's why this confusion is very much obvious. I mean, the intention is not to hurt you, but to let you know that this is how one should think about. So without realization, this is indeed a horizontal plane. So the plane of motion is not the shape of the track. The plane of motion is how you are negotiating the path. Okay. So even though the road is banked, the path is not, banked. The path is still, what we can say, horizontal. Okay. Let me move this. This is not nice. Okay. Now, so if I try to draw a car and all, it will be a difficult job for me. So I will draw like a point. Yes. And then draw the ability to realize things. So normal will act like this. And the gravity will act like this. And because I'm assuming it's a smooth surface, this is the only force. Now, if you try to look at the plane of motion, I hope you must have realized the plane of motion is this way.
Yes.
See, this is the plane of motion. The plane of motion is horizontal. Keep it flat. Yeah. If this is the plane of motion, and if this is the center, this is the radius of curvature. So this is the radius. Now the question is simple. Which force, will move the car on this track, and friction is absent. So which force can provide you the required centripetal force?
Sir, n sine theta I think, or n sine theta.
Correct. So it is the n sine theta which makes all difference, isn't it? So here you can see the normal was unemployed in the first case. So you can see normal was unemployed. Now the normal is employed. And that's the very first achievement we have done there. So we have put the normal to work. Now gravity is still unemployed. Gravity will do nothing. So the first step of the algorithm which I have given you, that you must resolve the forces along the plane and normal to
N
the plane.
cos theta is equal to
Correct. So the role of n cos theta is to balance the gravity, and that's it, nothing else. So n cos theta is always in. That's why you're not going down or n up. So now it is the n sine theta. And luckily the
is equal
n
to m.
theta is already directly along the center. So we need to do the further component thing. So component thing is not required. It is already along the center. So n sine theta is directly equals to MAC. Is this clear?
Yes, sir.
So if you divide the equation, that is tan theta, if I add 2 divided by 1, implies tan is AC by G. That's very simple. And then you can
RG tan
realize
theta.
that this is again V square by RG. So the only speed at which you can achieve this is when V is RG tan theta under root. So if you want to move on a like a banking of road, like the track which is banked. So on a banked track without friction, if you want to move or negotiate a circle of radius r, then your speed must be this. So now the question is, what happens if you move faster than this?
Sir, our the horizontal path will go little upward.
So of course, without friction, you don't move. Let's say if I throw some marble in a track like this, in a round track. So if I throw really fast, then the marble will go up the plane or down the plane.
Sir, on the plane.
Now, if the velocity will increase in value, then this object will go up the plane or down the plane. Now this is the speed at which the n cos theta is balancing the mg. Okay, and n sin theta is providing the centripetal force. So my question is, what happens if the velocity will increase than this value, the value which we just calculated? What will
We
happen?
will total
So it will go up or down?
down.
So with greater speed, it will go down. That is what you are trying to say.
What, sir?
So what I'm saying is, if this is the speed at which you can negotiate this circle. So if someone is trying to move faster than this, it will, then that guy will go down or up.
Sir, down, sir. Sir, inside. Sir, towards the radius.
Pardon?
One side towards the radius.
No. Look at this. So you are moving on this circular track. So this is the circle. Maybe I can draw this.
Sir, like slant towards the circle.
Now, if the car driver will, let's say if I increase, if I hit this car from the behind, and suddenly it starts moving faster than before. So will it go downside, like will it go like this or will it go like this?
Sir, sir, I thought you were talking about the inclination.
The inclination of the track is fixed. I am not going to change that, isn't it? So what I'm
Sir,
asking
no,
is,
car's inclination.
the car inclination is also fixed. Now how car can tilt more or less? Come on.
Sir, no, like, sir, if the car will travel at more speed than the limiting value of speed, then sir, then it will.
Okay, you don't understand anything. Look at this. So I need to explain something more. So first of all, you need to realize that the normal is acting something like this. I mean, difficult to draw. It's acting towards this. So normal is normal to the plane, of course. The idea is simple. If the speed will increase, and because the road is not straight, so the track will come in your path. It's like you're hitting the track here. You can think a kind of like this.
Yes.
So when you try to move or negotiate very fast, okay, do one thing.
Sir, understood.
Okay.
So we like providing the upper portion of the inclined plane.
Okay, so you do one small experiment. Take your palm. You can take your palm and just bend your palm slightly ahead. So your curls of the finger. You take a left palm. Take a left palm, and the fingers you curl towards right. Okay. Okay. And take a pen. Take a pen and move parallel to the palm. You can see it will hit the fingers because the front fingers are bent right. Take your left hand, make your palm vertical first of all. Once you make your palm vertical, then tilt the curls of the finger towards right. And then move the pen parallel to the palm. You can see it will hit the fingers, isn't it?
Yes, sir.
So imagine if you move the pen very fast, then the force between the pen and the finger will be high or low.
Hi, sir.
So when you try to move on a curved track which is bent in a way, basically the track has to change your inertia all the time because the track is coming in the path of the inertia. So the faster means the normal will grow very rapidly. So it is a normal reaction which will increase in its value if you try to move faster. Now this is generally difficult to understand. So normal on a curved track will grow in value. And if normal will increase in value, so n cos theta becomes more than mg, so it will try to go up, or you can say up the plane. So if I call it v naught, so if v is more than v naught, vehicle will slide up the plane. And if v is less than v naught, vehicle will slide down the plane. Okay, so that is idea. So vehicle will move up and down accordingly. Understood?
Yes.
Okay. So now the role of friction comes into picture now. So let's say the first question I have solved with assumption that there is no friction, but what if we have friction also? Then whether v is more than v naught or v is less than v naught, in both cases the tendency will be prevented by the friction, isn't it? So
Yes.
here I am assuming that the tan theta, okay, I mean not here. So now comes the next scenario. And the next scenario is if friction is present. Then you may increase your speed or you may decrease your speed, but the thing is the increment or the decrement will be prevented by the friction. So you will not slip immediately. So in the same track, if I assume that tan theta is more than coefficient of friction, so the repose angle is already crossed. So slipping is bound to happen. So it will slip down the plane. That is for sure. So if the repose angle is sorry, the angle of plane is more than angle of repose. So if you do not move, you will go down for sure. So now this vehicle the box. Anyway, so this vehicle, if you look carefully, so now we are going to take the case when you're trying to move with a speed less than. So if you try to move with a speed less than this value, what will be your tendency to go down or go up? So your tendency is to go down.
Go down.
Because, and
So the
therefore the
friction is acting downwards also, down the plane.
then friction will act up the plane. It always acts opposite to the tendency, isn't it? So if the
Yes.
object will try to go down, friction will act up. What happened to you guys? Understood? Tell me, is this clear? Yes or no?
Yes.
So then which force is pulling it down?
Pardon?
So which force is pulling it down?
Gravity is there. So if the tendency is to go down the plane, then friction will act up the plane. I mean, is there in doubt in this also?
No, sir.
No.
There should not be in doubt. So having said this, that mg is down normal and friction is acting like this, I'm looking for what is the lowest value of speed I can drive on this track. Because one thing is clear, that if I do not drive with any speed, I will fall down because the repose angle. And you need to also realize that this is not the motion happening this way. This is not laws of motion such chapter. Come on. This is circular motion chapter. So motion is happening this way. I mean, this imagination should be in your brain all the time. And keep in mind the track part. So I'm looking for the minimum velocity with which I can drive on the track. So minimum is definitely less than this value. So the friction, I will push the friction to its limit. Because if the limiting friction can balance, that is the lowest value I can drive with. So if I go beyond this value, again I will slip down. So now what we are trying to calculate is the minimum velocity with which you can move on a banked road. And the inclination of the bank road is definitely more than the repose. So in case if you go beyond this, you will go down for sure. Okay. So now write the steps which you have learned. The vertical force will balance out each other. So what I need to write here?
Sir, n cos theta is equal to mg. And
So how n cos theta is mg? Why you are not able to see the other force?
n cos theta plus fs sin theta is equal
Fs max is what? Mu s n.
to mu s
You should write in terms of n only. So mu s n.
And theta.
sin theta.
So you can take n common and you will get a cos theta plus mu s sin theta equals to mg. So here the n is also complex. So n is not simple formula. Okay, this is the first question. What is the other question? So there is no tangential forces because it's a uniform circular motion. So we need to look for the only net centripetal force. What is that? What is the value of centripetal force?
Centripetal. Oh, sir, it's n sin theta.
And
N sin theta n sin theta
Minus mu s
minus
mu s normal.
minus mu s n cos theta.
equals to
And v square by
mu
r.
square by r.
so I can write again I can take n common. I can write sin theta minus mu s cos theta equals to and because we have the n formula two times like equation 1 and 3 we just divide the formula. So 3 divided by 1 and we'll get the answer. This will give you what? V square by Rg equals to, just switching the sides, sine theta minus mu s cos theta upon, so the V becomes how much? Rg. So V is this much. So this is the minimum value of velocity. You cannot go beyond this, below. And this we can further write as by taking cos theta common is tan theta minus mu s. This is the way you will read in books. So I hope this is okay. And similarly, if you want to move really fast, in that case, the tendency will shift from down to up and friction will also reverse. So instead of acting up the plane, friction will start acting down the plane. So we say that so for Vmax, you just shift the direction of friction. Rest everything will remain as such. So now the normal way the way it is acting. But friction will shift the direction, not change the direction. So now I will show you the easier way of doing this problem. Like this is what we normally do. So now instead of solving by the n and mu s n, we can always solve by the method which you have learned in friction, the resultant. Right. So we know that in case of limiting friction, this angle, if I call this is alpha. So tan alpha we know is how much? Mu s, if you remember. Or you can make a triangle
Yes.
and you can see. And because that is alpha angle, so I can just draw a line like this. And I can find this angle also. This is theta. So let's say this angle is beta as of now. Not really. So you can free yourself from writing the various component. So you can write only one thing. What you can write? R cos beta equals to mv square by r. That's it. Simple. And what else you can write is r sin beta is mg. And therefore tan beta we can write as, yeah, I got something. Yeah, that's fine. So tan beta can get as g upon gr upon v square. That's coming opposite, but that's fine. So now what we can write the relation between the beta and alpha? So theta beta alpha we have relations. Theta plus beta plus alpha is 90 degrees, right? And therefore the beta we can write as 90 minus theta plus alpha. So basically tan beta becomes cot theta plus alpha. So tan theta plus alpha becomes cot beta because that is a really nice way of doing it. And then we can apply the tan A plus B formula, which is tan A plus tan B. So 1 minus tan A, tan B. And now we are done. Why we are done? Because we know tan alpha is mu s. So that's why this formula is exactly the same as what we got. But since we are doing for the maximum, so sign will reverse. So V max is GR.
So can you show the previous page?
That's all.
Okay. So now you have seen the banking of load, and we have left with some other varieties of questions. So maybe one lecture will finish this circular motion completely. This lecture. So now you're good to go with the most of the problem of SU and Erode as well. So with the theory given, this is sufficient. And I have given you two approaches to deal with the maximum minimum problem. One is the take each component and solve. This is the case. And this is the advanced method. Like this is what I always use for limiting case only. Okay. So this requires some more practice, more understanding. But once you master it, you can realize the power of this question. And bye guys.
Bye, sir.
Hello, sir.
Yes.
Sir, I want to
Tell me.